let it make sure it gets the problem on the recording. All right. Okay, so now we're going to look at the logarithm property of equality. Okay, so the same way we had the exponent law of property is that the bases are the same, then the exponents have to be equal if they're for it to be true. So let's say for any positive number b, where b doesn't equal 1, and x and y are both positive, say log base b of x equals log base b of y, just means that x has to equal y for that to be true. Okay, so these two are equivalent. All right, so let's say if we have, for example, if we wanted to solve 3 to the power of x equals 5. Okay, so this one's a little bit different from the other one because before we could make 64 equal 4 something, or 6 equals 6, or 36 equals 6 squared or something like that. Here, it's not really a way possible to make 5 have a base of 3. I mean, it's possible if you're really smart. I'm just not really smart, so I can't just do it in my head. So, we have 3x equals 5. We can apply log to both sides. Now you can apply log, you can apply natural log, you can apply log base 10, log base 2. Doesn't matter at all as long as they're the same on both sides. Okay, so let's say if you have log base 10, 3x equals log base 10 of 5. Okay. Now this is where you have to remember the power rule. Because remember, whenever you have a logarithm and you have an exponent, it can actually go down to the front. Okay, so this becomes x times log base 10 of 3 equals log base 10 of 5. Okay, divide both sides by log base 10 of 3. You have x equals log base 10 of 5 divided by log base 10 of 3. Okay. Now, if this were the exam, that would be your answer, but on the homework, they may want it as a decimal. So you'd actually plug that in, and you'd get 1.464, and so forth and so on. But they'll usually tell you how many decimal points they want. All right, so any questions on that one? All right. leave that up for a few more seconds. All right. Let's say, for example, wanted to solve 6 to the x minus 3 power equals 2 to the power of x. All right, so again, you can't take 6 and make it 2 to the power of something, so we're going to have to just apply log or natural log to both sides. Okay, so you have 6 to the x minus 3 equals 2 to the power of x, and this time we're just going to apply natural log. You'll get the same answer either way. So apply natural log to both sides. Okay, so that gives us the natural log of 6 to the x minus 3 power equals the natural log of 2 to the power of x. All right. Once again, that power rule comes into play. But this time it comes in for both sides, because that x minus 3 can come down to the front. Times the natural log of 6. And that x can come down over here times the natural log of 2. Okay. Now the goal here is once you get all of the x's down out of the exponents, you want to get all the x terms to one side and all the non-x terms to the other. Okay, so here we're going to actually distribute that natural log of 6. Okay, so at this point, your goal, get all x terms alone. Well, I guess you could say on one side. Alone isn't really correct. Okay, so if you distribute that natural log of 6, I'll move this over some. You get x times natural log of 6 minus 3 times natural log of 6 equals x times natural log of 2. Okay, so we're going to get this x and this x both on one side. So we want to subtract natural log of 2 to both sides and then add 3 natural log of 6. Okay, so if we add 3 natural log of 6 to both sides, those two, of course, cancel out. You have x natural log of 6 equals x natural log of 2 plus 3 natural log of 6. Okay, so now we're going to subtract x natural log of 2. Okay, so these two, of course, cancel out, just become 0. Uh-oh. So you have x natural log of 6 minus x natural log of 2 equals 3 natural log of 6. Okay. Now once you have both on one side, you can now factor an x out of both terms. Well, technically it'll be over there, but okay. So you have x times natural log of 6 minus natural log of 2 equals 3 times the natural log of 6. Okay. So now that you have that x factored out, you just divide both sides. So natural log of 6 minus the natural log of 2, and you divide the other side by the same thing. Okay, so anything divided by itself is just going to equal 1. So that cancels out. So you actually have x equals 3 natural log of 6 over natural log of 6 minus natural log of 2, which is your exact answer. But if you plug that into your calculator, it will end up being some value 4.892789, keeps on going and going and going. Okay, so on the exam, that will be your final answer. On the homework, they may ask for the decimal answer. All right, so any questions on that one? Okay. All right. All right, so let's say, for example, we wanted to solve log of 3x plus 2 equals log of 2x minus 3. All right, and just for a quick note, you actually have to check your solution for these problems, because a lot of them it's optional to check, but for problems like this, you actually have to check, and I'll show you why in a second. Okay, so checking your answer is not optional. Okay, so we know that log of 3x plus 2 equals log of 2x minus 3. They're both same base, both log functions, so that means 3x plus 2 has to equal 2x minus 3, just for that to be true. Okay, so if we solve for x, you plug in negative here, subtract 2x here. 2x minus 2x is 0, so that disappears. So we end up with x plus 2 equals negative 3. Subtract 2 from both sides. X equals negative 5. Okay. So now we just plug it in and check it. Okay, so log of 3 times negative 5 plus 2 equals log of 2 times negative 5 minus 3. Okay. 3 times negative 5 is negative 15, plus 2 is negative 13. So you have log of negative 13 equals 2 times negative 5 is negative 10, minus 3 is negative 13. Log of negative 13. So it's true, but it's still no solution. Because remember, it has to be greater than 0. Your x and y has to be positive. Okay? Since the log of a negative number does not exist, or undefined, this equation has no solution. Okay, so it'd either be no solution for your answer, or just empty set. Each problem will tell you which one to put. It'll say if it's no solution, write no solution, or empty set. All right, so any questions on that one? Okay. So now we're going to kind of use everything we have to solve logarithmic equations. So you want to still write any? All right. Leave that up for a few seconds. All right. Okay, so let's say, for example, I want to solve log of x plus log of x minus 3 equals 1. All right, so I'm just going to rewrite it. Real quick. And you know, whenever you see that plus sign, that means the product rule. Of logarithms. Okay, and remember that's just log of A plus log of B equals log of A times B. Which is really, first couple times we did it the other direction, but it works both ways. Okay, so since these are both common logarithms, you can just rewrite them as log of x times x minus 3 equals 1. Now remember, it's a common logarithm, so technically it's log base 10. Okay. Now once you get it down to one single logarithm, you want to remember that log base b of x equals y can be rewritten as base to the power of y equals x. So in this case, since your base is equal 10, 10 to the power of 1 equals, well, this would be your x value. So you can actually rewrite this as 10 to the power of 1 equals x times x minus 3. So 3 is a little bit messy here. Okay, so does that make sense? All right. Okay. Now from there, you just solve for x. Okay, so you have x squared minus 3x equals 10. Or subtract 10 from both sides. X squared minus 3x minus 10 equals 0. Okay, so we can go ahead and factor those. Just have to find two numbers that multiply to equal our c, which is negative 10. And those same two numbers add to equal our b, which is negative 3. Okay, so for this one, negative 5 and 2 looks like it works. Okay, so we can actually rewrite this as x minus 5 times x plus 2 equals 0. Okay, which means x can equal 5 or x can equal negative 2. Okay, so right now you just have to check them. And you can see automatically from that negative 2 that if you plug it into that first one, it won't be defined. Okay, so we'll check the x equals negative 2 first. So that's log of negative 2 plus log of negative 2 minus 3 equals 1. So both of those are undefined. So your x equals negative 2, not a solution. But if you plug in x equals 5, you end up with log of 5 plus log of 5 minus 3 equals 1. This gives you log of 5 plus log of 2 equals 1. Okay. Now you don't have to actually go through the entire process of solving it. You just want to make sure you don't have any negative numbers in there. So once you see you don't have any negative numbers for plugging in 5, you're okay. Let's say your only solution. All right, so any questions on that one? All right, leave that up for a few seconds. Okay, now if you did want to go all the way through with this one, let's say log base 10, log base 10. If you want to combine these two, log base 10 of 5 times 2. So that's just really log base 10 of 10 equals 1. Which means 10 to the power of 1 equals 10, which is true. Uh-oh. Must have a loose connection somewhere. That's a little bit messy looking. All right. Oh, I'm sorry. Was anyone still writing that one? Normally I'd look up to make sure, but I think I just grabbed it. Okay, so let's say if we wanted to solve log base 2 of 7 minus log base 2 of x equals 5. right, so go ahead and rewind it. Not rewrite it. I don't know why I said rewind. Log base 2 of 7 minus log base 2 of x equals 5. Whenever you see that minus sign, you know automatically you're going to use the quotient rule for logs. Okay, which is if you have log base b of m minus log base b of n, then that's going to equal log base b of m divided by n. Make that a little bit bigger. Okay, so that means these two terms are going to become log base 2 of 7 over x equals 5. Okay. And once you have it to that one term, again, you want to remember that log base b of x equals y is equivalent to b to the power of y equals x. Okay, so this can actually become 2 to the power of 5 equals 7 over x. Okay. Or 2 times 2 times 2 times 2 times 2 is just 32 equals 7 over x. Okay, so if we multiply both sides by x, we end up with 32x equals 7. Divide both sides by 32. X equals 7 over 32. Okay. And again, we just plug in just to make sure we don't have any negatives lying anywhere. Okay. So if we check it, you have log base 2 of 7 minus log base 2 of 7 over 32 equals 5. Okay, so again, we're just going to go ahead and divide those two since we're using the quotient rule for minus signs. So log base 2 of 7, divided by, I can just do that. 7 over 32 equals 5. Now, using our rules for dividing fractions, you have log base 2. Write down your first fraction. You can make that 7 over 1 if you want. Change division to multiplication, and then you just flip your second fraction. Equals 5. So the two 7s cancel each other out, so we don't have to worry about those anymore. So we end up with log base 2 of 32 over 1. 32 is equal to 5. 2 to the power of 5 equals 32. If we rewrite it, which is 32 equals 32, so that's actually true. Okay, so we can actually tell just from the very beginning, if we look at our original problem, if we plugged in 7 over 32, it would be positive. The rest of it was just to make sure we had the right answer. All right, so any